Peter Lanjouw, if I pronounced his last name correctly, is Dutch. And he is a research manager for poverty, economics research, development, World Bank. He's honorary partner of the Institute in Amsterdam. He studied at the London School in Economics, and between August 03 to 05, he visited the economics department and resources at the University of California in Berkeley. He was designated professor of economics at the VU University in Amsterdam. September 1998 and May of the year 2000. He's been a professor, economics for development, master's degree in Belgium, and he has also been a professor at the Advanced Studies Foundation, Tokyo, Japan. His research focuses on various aspects of poverty and inequality. You have the floor, Professor. Thank you, Alfredo. It is an honor and a great pleasure to be here with you today and once again be able to talk about this issue. I'm sorry, we're having audio problems. I will be making my presentation in English, but if there are any questions, if there's anything that's not clear, I can also try to explain in Spanish, but English is a little easier for me.
Okay, so thank you very much. I'm going to talk today about half an hour about the work that we've been doing in the research department at the World Bank within the broad area of small area estimation that was described well by Professor Rao, but more specifically on the specific question of estimating small area estimates of poverty. And as Dr. Rao, Professor Rao already emphasized, this is a topic of real practical interest and real practical importance, and I will spend a little bit of time talking a little bit about some of the reasons why there is a demand for these poverty maps in many of the countries that the World Bank is involved with. And I should say here that it's been a great pleasure for me and work with colleagues here at Coneval, Ricardo Aparacios, and in Mexico to also work over the past 5-10 years on various attempts to estimate poverty at the local level in Mexico. And it's been a real learning experience for us as well. And it's one of the things that we're continuing to do. I'll explain a little bit in some additional detail the method that we apply, but without going into it in too great length. I believe that there is considerable experience already with the approach that we take here in Mexico. So I will touch on the details and give a quick overview, but not dwell on it too much. I'd rather spend a bit more time in the time that's been allocated to me to talk about some validation work we've done. And Professor Rao already emphasized the need to do external validations and the importance of this type of work. And that's certainly something that we've taken very seriously. We have a particular approach for estimating poverty, but we've been very careful to also try to validate this wherever we can. And I'll describe one particular validation exercise that we carried out in Brazil using Brazilian data. And I will describe a little bit some of the current work that we're doing on validation as well in the context of the European Union and recent accession countries in the European Union. So why is there such an interest in small area estimation of poverty? Something Professor Rao already highlighted. It's something that he emphasizes it's one of the reasons this is such an exciting area to be working in. It's an area that there's a lot of demand, there's a lot of interest. It's useful perhaps to reflect a little bit on why that might be. Well, There is this great process underway throughout the world of decentralization, of looking at the local level, to looking at the local areas, to sort of get our cues to how to produce the development process. There's growing evidence that as countries get richer, spatial disparities, rather than becoming narrower, can at times become more accentuated. And we need to have information that tracks that documents that information. Many countries throughout the world, I believe in Mexico too, but many an active policy or an active practice of targeting resources to on a geographic basis, to go to local areas and to target resources in that way. Not just in developing countries, but as we heard from Professor Rao this morning, also in the United States with the SIPE program and so on. There's an interest in knowing about outcomes at the local level for the purpose of targeting resources for specific. There's a lot of discussion these days about lagging areas and leading areas. The broad process of economic development is not a process that occurs uniformly across all regions of a country. There's those parts of the country that are falling behind and those parts that are leading that process. And it's very important to be able to identify where those things are happening and to be able to track that over time. Centralization of governance. There's a great emphasis on local level decision making, local level implementation of projects and of politics. That local level effort needs to be informed by information that's pertinent at the local level. So we need to have information at the local level. And so this is, again, one of the reasons that there's so much thought and reflection going on about how to get information, how to have indicators. When we talk specifically about poverty, one of the emerging findings that's quite a regular, consistent pattern across countries is that we may have areas which have high poverty rates or high incidence of poverty, and then other areas which have low poverty rates, but that the patterns of geographic pattern of poverty rates, poverty incidence or prevalence, not necessarily match the population of poor people. You might find areas that have very low poverty rates having very large numbers of poor people, also very densely populated. The whole need to track poverty at the local level is a subtle one. It involves looking not just at estimates of poverty, but also looking at population movements. So the poverty mapping work at the World Bank is something I've been involved with right since its inception, and it started in the work that we were doing in Ecuador. The specific context was that there was a household survey that had been completed. As these household surveys in countries like Ecuador go, the sample size was very small. So there wasn't a lot of scope for disaggregating and producing. At the same time, there was a population census that had just been completed. The data at the population census were not really being exploited. It occurred to us that if we started trying to combine these data sources, we might be able to make some progress in being able to produce. Is this better like this? Being able to produce estimates of poverty at the local level. Since that time, there's been a number of papers written. The sort of main reference that we point to is a 2003 paper that we wrote documenting in some detail the methodology. But there's been ongoing work that's been continuing, including work very recently, as Professor Rao was emphasizing. It's an area of very active current research, also even within just simply the World Bank's research department. We have been, in parallel to working on the sort of methodological issues, also trying to operationalize, to make it possible to implement these methodologies in a fairly tractable and a straightforward way by also designing and developing software that assists with the process of producing these small area estimates. I mean, I should reiterate, though, that I completely subscribe to Professor Rao's view that these things should not be done casually and that there is no excuse for taking the time and concerted attention to each poverty mapping exercise, and the software is only there to sort of help that process along, and it's not a substitute for the careful process. At present, at the World Bank, we've been involved in poverty mapping exercises in around 70 or 80 countries since since the start of the 1990s. And that includes some of the very large countries like China and India, Brazil, Indonesia, where we have very large logistical issues to confront just simply because the censuses that we're working with are just so enormous, and the computational challenges are really great. And for that reason, the software that we've developed has been really essential. The basic idea of the poverty mapping approach that we've been implementing is follows very closely in spirit many of the elements that were already emphasized by Professor Rao. What we do is we impute a measure of consumption or of income from a household survey into the population census at the unit record level using sort of prediction methods. One of the appealing features of this is that we work with exactly the same concept of poverty or of well-being, income say, that we're comfortable and that we normally work with when we work only with the household survey data at the national level. And yet we intend to go all the way down to the local level and produce estimates of poverty that are coherent and that are interpreted in exactly the same way. I should say this because in the past, prior to this development of small area estimation, there was a lot of efforts underway in many different countries to produce poverty measures of some type at the local level, using just census data, say, or using other types of data sources that were available. Very often they involved changing the definition of poverty, using a different criterion for what poverty means in order to be able to produce some kind of a number for these local small areas. And that then led to all kinds of confusion as to how to interpret those numbers. One of the appealing features of the approach here, of all these small area estimation approaches, is it does not involve changing the underlying concept that we're trying to work with. One of the additional features that's attractive with this approach is that the statistical precision is something that we take seriously, and we want to be able to follow. We want to make sure that we're producing estimates that are not only that we're not only able to produce a complete picture of a complete map of poverty at the local level, but that it's also reliable and that it's also statistically precise. Yeah. In our opinion, the results that we've been getting have been fairly encouraging. It's something that's difficult to establish clearly, but we've strong response from countries which we've been working with, and so this gives us encouragement to continue develop these and refining these methods. But I think at the same time, and this is certainly something that's true in Mexico, is it's very clear that the data requirements to implement this procedure are non-negligible. You need very good quality household survey data. You need to have access to population census data at the unit record level, something which I think historically in many countries was not normally even granted, and even today in many countries access is still restricted in all kinds of ways. So that's something that also makes the whole exercise particularly challenging. Now, the requirements of the procedure is that the household survey and the population census should have variables in common. The questionnaires have to have corresponding definitions and corresponding variables, and they should. The kind of variables that are common in both the population census survey questionnaire and the survey questionnaire should also be correlated with consumption or income. I should be using consumption or income as my welfare indicator simply because we use both of them. It depends on the country and the context. It's in our particular approach, it's very important that the population survey and the census can be linked at the cluster level, i.e. that the household survey, which is in most cases that our experiences of working is with sort of complex design household surveys that have both stratification and clustering, and that these clusters have some kind of counterpart that can be covered or identified in the population census. It's very often a very straightforward tasks, because very often the cluster in the household survey is simply equal to the enumeration area in the census. It's helpful, although not essential, but it's very helpful in our experience that the census should include variables that capture location-specific effects, or that we have other data sources that have, say, infrastructure variables or information about geographic characteristics that we can link to both the survey and the census. And then, of course, it's important for the whole purpose of the exercise that the census should enjoy large coverage. Context where there's a census that doesn't cover a particular part of the country, well, then we wouldn't also be able to produce any small area estimates. This is in fact what happened in Ecuador in the more recent 2000 census, where they did not cover part of the Amazon region, and so we were not able to produce poverty small area estimates for that region. Now, in the method that we use, what we do is we estimate a model of per capita log income or consumption using the sample survey data, and we restrict the explanatory variables in that model to those that can be linked to both the household survey and the census. And we then estimate the expected level of poverty or inequality for a target population, a small area, using its census-based characteristics and the model that we've estimated for Y. We, as Professor Rao also focused on, we basically work with a standard random effects model for Y. In our case, we have log per capita consumption or income on the left-hand side, a number of household and area level characteristics as sort of explanatory variables, and then a random effect at the cluster level, primary sampling unit level. Idiosyncratic error. Now we estimate Y by evaluating its expected value given the model for Y, so we have expected mu is our estimate, and this expected value of W given conditional on X and theta, which is the vector of model parameters from that model. And the difference between W and mu is due to the fact that W is a function of the true mu and the true epsilons. And in practice, theta, the vector of parameters, is replaced with a consistent estimates, which yields mu tilde as an estimator for W. We produce estimates that are then estimated with some error, and that error can be decomposed into a number of components. We have one component which we designate the idiosyncratic error, another one which is a model error, a computation error, and then there can be even sampling error if the population census is a sample rather than a full population census. These different errors have different properties. One key property of the idiosyncratic error is that it varies with the size of the populations in the target populations in the areas that we're estimating poverty for. The larger those areas, the smaller the idiosyncratic error becomes, and so we're left largely with model error as the key source. At the very local level, though, the idiosyncratic error can become very, very significant. And this is also what prevents us from using this methodology from estimating, say, poverty at the level of individual households in the population census. We wouldn't be able to produce estimates at the level of the household with any kind of confidence because it would be very imprecise. We apply simulation to the bootstrapping procedure that was outlined by Professor Rao to produce the standard errors for the estimates. Estimate these beta hats and the parameters, model parameters, and we basically apply a bootstrap replication R to simulate this Y tilde for every household in the population census, where the model parameters and the errors are then drawn from their estimated distribution. We evaluate W tilde for each bootstrap simulation. So if W is the head count rate, the poverty rate, then we would estimate that for every bootstrap simulation. And then we apply R bootstrap simulations and obtain the average over those R simulated values to estimate our head count rate or our welfare indicator W. And the standard deviation over those simulated values denotes the estimates of the standard errors. Now, just some of the features of the approach, or some of the details. We draw the model parameters from parametric and empirical distributions. We estimate from the bootstrapped data. Now we control for a very important thing. It's something that's become very clear, increasingly clear as we've increased our experience with this whole approach, is that we should control as much as possible for area characteristics in the household model. So we include not only explanatory variables at the household level in our prediction model, but include also variables that capture the characteristics of the area. One way that we can do that quite straightforwardly is to calculate means in the population census and insert those means of each area into the household survey, and then include those means as explanatory variables in our model. The use of these variables allow us to control the size, or at least try to minimize the size of the unexplained variance at the cluster level in our model, and that's something that's very important for the subsequent precision of our estimates. Another thing that's very important, and this came up also, I think Professor Rao alluded to in his presentation, is these models, to try to avoid having them become too big and too complex, to avoid overfitting. So the question arose this morning about whether we should be estimating models separately for different strata or having one model. One of the risks of estimating a model at the stratum level is that you then have fewer household observations with which you're working with. The sample size of the survey becomes smaller, and it's easier to fall into the trap of having an overfitting problem. And having one model for the whole country is somewhat safer from that point of view. At the same time, it is important to allow for the fact that, say, returns to education in an urban area might be different from returns to education in a rural area, and we also want to try to capture that. And so the way to do that is to include these stratum-level variables into the model, interact them with, say, household-level characteristics that seem particularly important. So the experience is that, yes, the regions and the different strata should be allowed to have an influence, at least potentially, in these models, but whether the model should be estimated separately or one single model is something that still needs to be looked at very carefully. And at all costs, one wants to avoid overfitting. There's sometimes, perhaps in the statistics community, that's not so much of an issue, but when I make presentations about this approach to economists, I always get a lot of feedback about how to interpret these models that we're estimating, and whether aren't going to be all kinds of endogeneity problems and biases and so on. And the answer is yes, indeed. And in fact, the endogeneity bias, due to, say, reverse causality, can actually be a good thing in these prediction models. Key thing to remember, as Professor Rao also emphasized, is that we're talking about prediction models here, and we're not talking about models that explain outcomes in a way. So we're not trying to find causal determinants of, say, income or consumption. We're just trying to predict income or consumption. And so having a variable which is associated with a dependent variable through reverse causation is perfectly fine from this prediction perspective. Another thing that is important to think about when implying this method in countries is that in many countries, and I'm sure this is true in Mexico, given the size of the country, there's likely to be considerable spatial heterogeneity in the cost of living. And when we want to measure poverty, we want to make sure that we've taken that into account. And so there is a need to think also right before we even embark on any of these small area estimation procedures to make sure that we're comparing like with like in different parts of the country, that our measure of income that we're using has been adjusted for potentially important spatial cost of living variation. Now, there's a number of assumptions, obviously, that are underpinning this type of approach. One of the key assumptions is what we call the area homogeneity assumption, in which we assume essentially that the distribution of y conditional on x is the same across domains. We're estimating a model, say, at the national level, and then we assume that within the national level, at the local level, the same relationship holds. And that assumption could fail if there is heterogeneity in returns to education that is not accounted, or other variables that is not accounted for in the model. So it's something that needs to be acknowledged right from the beginning, that we are making these types of assumptions. We also assume that we've successfully identified the true model. Professor Rao emphasized the importance of thinking about these models and thinking hard about these models, and that's something that is absolutely important. We assume that the variables from the survey and the census are comparable. Now, we do a lot of work to try to establish that, and that makes that assumption perhaps seem less binding, but it is something that we are assuming, and the whole thing falls down if that isn't the case. It's easy to fall into the trap of thinking that variables are comparable. For example, I've had the experience of looking at a household survey where we have a variable such as household size, which is an important variable and helps predict income quite well. But the definition of the household in the census and in the survey may not be identical. And so then the two variables aren't, the household size variable is not strictly comparable between the census and the survey. That can then lead to very misleading conclusions and problematic estimates. Often, it's also the case that we don't have a household survey and a population census that coincide exactly for the same time period. In practical cases, that's almost never the case. And so we often have to make additional assumptions then about the stability of the model and the parameter estimates over time if there is a gap between the household survey and the census. And those assumptions can be quite controversial if there happens to be major structural changes, economic crisis or something like that that's going on. As a result of all these assumptions and all these methodological concerns, it really is important, and I just want to underscore that Professor Rao also emphasized, the need to sort of validate, to do these external validations wherever possible. Now, when we implement poverty mapping efforts in countries, we try to encourage our counterparts with whom we're working to do as much of this type of validation as possible. Sometimes that validation will be of a kind of informal nature, involving visits to small areas to just get a sense of whether the kind of poverty estimates that are coming out make sense. Also, if you happen to go to these places, that can be quite informal, but still very informative. Look at other indicators of well-being. Do they line up with the kind of estimates of poverty that we're getting? There might be a role for discussion and public discussion to get feedback from people as to whether these kind of numbers are making sense. There's a number of exercises that can be carried out to try to validate. It's also at times possible, in the ideal case, when one has, say, some evidence or some data on the truth, and one can actually check the estimates that have been produced against the true poverty rate in the local area, then that's obviously a more rigorous way of doing this kind of external validation. And when those opportunities arise, it's well worth pursuing them. We, in fact, did a little mini validation exercise using the Progresa data here in Mexico for the Progresa project. They had collected a census of households in rural Mexico in 500 villages. So they had detailed information about income from the entire population of 500 villages. And so some 20,000 households, I believe it was. So what we did is we took that population and we drew a sample, household survey sample from that population of 500 households, and then pretended we didn't have the information about income in all those other households that were not included in our survey, in our pseudo-survey. And we then applied the poverty mapping method to these data, and then checked ultimately at the poverty rates in the villages. We estimated the poverty rate for the villages and then checked against the true poverty rate in the villages to try to get a sense of how well that the procedure was going. And the results from that exercise were encouraging, but also given the way that the Progresa census data had been collected, it wasn't possible to really sort of answer all possible questions about the methodology in that approach. So in my remaining time, I'm going to try to spend a little bit of time talking about a similar validation exercise that was carried out in Brazil by myself and my colleagues Chris Elvers and Felipe Leite. Now, Brazil is an interesting country because they have a population census and they collect census data. So we were working with the census data from 2000. And in the census of Brazil, they actually collect an income measure. And the way the census is organized, at least 2000 census, was they had a thin round, which covered 87.5% of the population, which collected just a single question on income. And that measure of income was not judged to be very high quality. So it's a pretty controversial measure to be working with. But at the same time, they also collected a thick round in the census, which is a sample of 12.5%. And that component, or that part of the census, that thick round, actually calculated a reasonably comprehensive measure of income, so that there was actually somewhat credible data at the level of each household in that thick round of the income level of that household. What we did is we decided to work with those data, and we chose to focus on the state of Minas Gerais, which is one of the large states in Brazil, just for the purpose of computational ease, so that we wouldn't have to work with millions and millions of observations. We worked with slightly more manageable data set of 606,000 households that were covered in this 12.5% sample of Minas Gerais. And that 12.5% sample covered all 853 municipalities in Minas Gerais. And the municipality is the local government, level of government for which poverty map estimates have been desired in the Brazil case. Now, the state of Minas Gerais is an interesting state in which to implement this procedure because it's a large state in the central Brazil, and it resembles in many respects, the state itself resembles in many respects Brazil as a whole. And you can see that in this map here, where we see the state of Minas Gerais, where in the northern part of Minas Gerais, income levels are much lower than in the southern part, in the southeastern part of, or southwestern part of Minas Gerais. And that pattern is actually exactly what you see if you look at Brazil as a whole. The northeastern part of Brazil, it tends to have much lower income levels than the south and the southwestern parts of Brazil, the center and the southwestern parts of Brazil. This is true not just in terms of income, but you also see similar patterns in terms of infant mortality rate and life expectancy. So it's a state that in some respects is highly heterogeneous, with a lot of heterogeneity within the state. Some parts of the state looking very poor and other parts of the state looking much better off. So what we chose to do in this exercise was to take 41 pseudo samples, and I'll say a little bit more about the choice of these pseudo samples, but we had chose to estimate, we drew 40 pseudo samples from this 12.5% thick round census for Minas Gerais. And we chose these pseudo samples in such a way as to mimic the sample design of Brazil's two main household surveys. Brazil has two main household surveys that it uses for the measurement of poverty and income distribution. One of them is called the POF, which is a household survey that collects information on consumption. And so we had 20 surveys that mimic the sample design of the POF, which is a sample size of about 2,800 households. So from the 600,000 households in Minas Gerais, in the census, we drew a sample of 2,800 households. In fact, we drew 20 samples following the sample design of the POF survey. And then we drew 21 surveys followed the sample of the PNAD household survey, which is a much larger employment survey in Brazil. And we have 21 surveys that have a sample size of 12,000 households. The question that we were seeking to investigate was how well does this poverty mapping methodology applied to these pseudo surveys predict poverty in each of the 853 municipalities in Minas Gerais. The PUF surveys, the ones with 2,800 households, were covering some 150 or so municipalities. So there was a subset of all the municipalities included in the sample. And in the PNAD surveys, although the sample size of the PNAD survey was much larger, it only covered 170 of the 853 municipalities. And that kind of ratio is what we often find in the kind of countries that we've been working at, i.e. not the kind of context where there's data in the sample for almost all of the target populations. This is some of the point that was brought up earlier in Professor Rao's presentation. We generally work in the countries that we've been working with. We are generally working with data sets, household surveys, where there's a very small fraction of target populations included in the sample, and that has informed or influenced the way the methods that we've So a first assessment of the quality of how well this small area estimation procedure that we've been working with works is to simply look at the poverty rates, the predicted poverty rates in each of the 853 municipalities once we've predicted it into these 853 municipalities using this method, and then to compare that to the true poverty rate in each of these 853 methods. And what you see is that there's a very strong correspondence between the estimates that we've produced and the estimates and the true poverty rates in those municipalities. There's a correlation of 0.88 between these two sets of estimates, and you can see that the very large municipalities, the ones that have the larger circles, are lining up very closely on the diagonal, and there's a little bit more dispersion for the very small ones, where we would also expect the estimates to be slightly more noisy. But the overall assessment, and this is a picture drawn for just one of the pseudo surveys, but if we do 41 of these pseudo surveys, we get essentially 41 examples of very high correspondence in the poverty rates that we've estimated and the poverty rates that truly apply in those local areas. If we look at the precision of the poverty estimates, we can think about that in a different number of ways to ask how well are we doing in terms of the standard errors that we're calculating on these poverty estimates. Because as I emphasized, we're interested not only in producing a point estimate, but we're also interested in tracking the precision of those point estimates. We find that, again, the approach seems to have worked quite well in this Brazilian case. We have in this graph here, in this picture here, we have 41 surveys, and we see that in almost all of the surveys, most of the municipalities we produced estimates of poverty for most of the municipalities with a confidence interval which encompassed the true poverty rate in those municipalities around 95% of the time, which is roughly what we would be expecting with our confidence interval of 95%. So we're more or less getting what we were expecting with our standard errors. They seem to be delivering what we were looking for. You can see there's some details that have to be thought through. One of the things that's very important in the context of our methodology is when we estimate our standard errors, there's a component of the standard error that's attributable to a location effect. And the location effect that we use the location effect that we try to incorporate into our estimates is based on the variation that we see in unobserved location effect across the clusters. And the question that we have to ask ourselves is whether when we apply our estimates to the census, should we be taking our estimated variation of the location effect to the cluster in the census, or should we be applying it to the target population, the small area level in the population census? What we've done here in these two figures is that we can show what the consequence would be of making the two alternative choices. The right-hand side figure shows of the poverty rates with a much tighter band of confidence intervals. Because here we're making an assumption that there is no location effect beyond the cluster level, and that there is no, say, location effect at the target population level. And that leads to overly optimistic estimates of our standard errors. Our standard errors look smaller than they really should be. On the other hand, if we apply the assumption that our location effect, which we've estimated at the cluster level, and if we impose the assumption that that cluster level location effect actually applies at the small area level, which is a conservative assumption, then we find that the standard errors are wider. And these are the standard errors that we've reported in so it is important to think hard about how to apply the methodology. A final robustness check we did is there's some arbitrariness in deciding to work with 41 household surveys, pseudo-surveys. It's a little bit, it sort of stands in the middle between being a scientific exercise and a kind of home and alone in the kitchen type of kitchen sink type of exercise, because 41 pseudo surveys is not really enough to really be a true sort of Monte Carlo kind of assessment of the methodology. But the tricky thing is that in our approach, what we do is we allowed for a different model to be selected for each one of these 41 surveys, because we felt that for your given survey, you then optimize your model for the particular sample that you have and you produce your estimate. But to do that for thousands and thousands of pseudo surveys would have been a very cumbersome and time-consuming exercise. As a final experiment, we decided, well, suppose we choose just one model specification and we apply that to 1,000 pseudo-surveys. And so we applied that to 1,000 pseudo-surveys of the PNAD type. We drew 1,000 draws from the population census. Same model in each of those pseudo-surveys, and then produced our estimates of poverty and calculated our standard errors. And then in this particular graph, we see that in the vast majority of municipalities, we would produce 1,000 estimates of poverty and their corresponding standard errors in each of the municipalities. And then those estimates are almost, in all cases, very high fraction of good prediction. So again, we see that as sort of a confirmation that the methodology was working quite well. Now, I mentioned earlier, just to finish, that we're currently involved in a large project in the EU region where we're looking at 10 accession countries, and we're going to be estimating poverty in 10 recent accession countries to the EU, the local level. And we're going to be applying the ELL method that I've been describing, and also comparing it with other methods such as the EB method that Professor Rao was describing, as well as some further refinements that we're working on that was also mentioned earlier using the normal mixture models. So the nice appealing feature of this exercise is that we have two countries, Denmark and Slovenia, which have administrative data for every household in the country, which has very detailed information on income. So we can redo the kind of validation exercise that I was describing in Brazil. We can redo this validation exercise in Denmark and Slovenia. And we can compare the different approaches we can look at the impact of different sampling designs, and we can try to get a sense of how these different methods all work under these different types of approaches, and be able to hopefully come back and sometime soon with some results from that exercise. So I will end there, and thank you very much for your attention.
Bueno, ahora toca hacer algunos comentarios sobre el trabajo. Realmente, después de estos días que hemos pasado aquí, queda muy claro que que hace 2 días yo pensaba era la primera aplicación de métodos de para en realidad se inició un tiempo antes y efectivamente queda claro que todavía y afortunadamente mucho área se convertirá en un área por ello, siento que es totalmente lo señalado en la última lo que viene, lo que falta por hacer, tal vez pudiéramos abusar un poco, ¿no? y pedir, bueno, qué va a ocurrir, cómo se acerca lo que hemos estado platicando, en fin, para darnos una idea más cercana de qué podemos esperar.
The question the question of what are perhaps some of the things that we could be expecting to see in some of the ongoing research that's underway at the moment. And I guess one of the things that we will be wanting to do is, I guess I should step back and say one of the very nice things that I feel over the last few years has been, we started working on the poverty mapping approach that we've implemented at the World Bank in the early 1990s. And for a long period of time, we were doing this work somewhat in isolation. And I think in the last 2 years, 2 or 3 years, we've had a much closer integration with the small area statistics field. We've had the opportunity to interact with Professor Rao and Isabel, and been engaging, also attending International Statistical Institute meetings and so on. And there's been a lot more cross-fertilization, I think, in terms of how to go about doing these things. So one of the things that we've learned since our conversations with Professor Rao started about 2 years ago is this empirical best method that he and Isabel Molina have developed, and that was published in their 2010 paper in the Canadian Journal of Statistics. That paper shows that there are potentially very important gains, efficiency gains, over the method that we apply. And this is obviously something that when we discovered this was something we wanted to look at very closely, because while I think the point estimates that we are producing are probably okay, the precision of those estimates is not necessarily always as good as we would like. And the opportunity to look at alternative methods that may actually help us get much greater precision is something that we need to take very seriously. As we studied the method, it became clear to us, though, that the starting point of these two approaches has been a little bit different. As I emphasized earlier, we are often working in a context where we have samples that have that cover only very small fraction of the target populations for which we are going to be producing estimates of poverty or well-being. And I think many of the gains from the EB method will be coming in those cases where we do have some sample data in our target populations. Now, as Professor Rao was emphasizing, going forward, we should be taking preventative measures, right? We should be trying to avoid the need to be going for these small area statistic methods. One of the messages he made was that we should be doing perhaps more stratification, that we should be designing our sample surveys in such a way so as to cover more of the target populations for which we will ultimately be producing small area estimates. To the extent that that happens, to the extent that we do see sample sizes in the countries that we're working with, capturing larger numbers and larger fractions of the target populations for which we'll be producing estimates, we will be able to draw much more heavily on these refinements that the Rao paper have pointed to us. I wanted to emphasize that the software that we've developed, and I didn't show the slide here, but we've developed this poverty map. What we're doing is incorporating it into that software, also the ability to estimate the Molina and Rao estimates. So all the work that we're doing in Europe now, we will be producing estimates of poverty using the sort of standard ELL method, but also using the empirical best approach. And we'll also add to that as we develop further some of the refinements that we're working on with using numerical using normal mixture models. So this is a process of learning from each other and then taking it and applying that and using it so as to be able to produce stronger and better estimates of poverty. And it's an extremely exciting area, and I just wanted to return back to the point that Professor Rao made and that I also made in the beginning, which is that it's a really important area. There's an enormous demand and there's an important need for this type of information at the local level. And it's not an option for most countries of the world to do what America does, which is to go calculate the American Community Survey, where they go collect a sample size of 2.5 million households every year. This is not an option for most countries of the world. It's far too expensive. It's probably also technically really challenging for most statistical offices to manage surveys of that size. So in the absence of that kind of data, we can't rely on direct estimates at the very local level. We need to think about these alternatives, and I think there's a lot of exciting and prospects for good results on that front.
¿Hay alguna pregunta de parte del público? Por favor, sí.
De pobreza, no solo bajo el enfoque monetario, básicamente hoy día tenemos que hacerlo con ingresos hacerlo para 6 variables que son binarias, que representan carencias específicas en el ámbito de la salud, 2 variables vinculadas con la vivienda y una variable vinculada con la alimentación y otra con la seguridad social. Además, necesitamos tener estimaciones que las hemos aproximado a través del índice de Gini, particularmente en la todas estas deben ser integradas y hay una propiedad que debe tener que es particularmente importante en tanto investigación como propiedad de desagregación por subpoblación. No solo necesitamos estimar a nivel municipal en nuestro caso. Y además esas deben ser consistentes con otro tipo de, como son por grupos de edad o algunos otros tipos de poblaciones específicas geográficas. Yo conozco dos aplicaciones que se han hecho. Una la hizo el doctor, la otra la hizo el doctor. Desarrollamos años, pero me gustaría saber, ¿conoces aplicaciones donde las variables no solo sean sino también en variables que pueden ser
The question was is whether there are other examples of sort of small area estimation methods or applications in a context where the variable of interest is not a continuous variable but a variable that's a categorical variable or some kind of non-continuous type of variable. And unfortunately, I don't have a lot of experience of other approaches, not because I don't see the great importance, and it's something that's been sort of on our to-do list for a long time, but it also seems like it's necessary to go back to first principles and sort of think about how we want to do that, how we want to make those kind of predictions. There has been a little bit of work, for example, I think in the context of poverty, where there was Professor Angus Deaton recommending that instead of estimating a consumption model and then using a consumption model to estimate the poverty rate, we should be doing some kind of direct estimate of the poverty rate. And so there are some non-parametric approaches that he has outlined for doing that, not so much in the context of poverty mapping, but just in the context of doing that within a survey. One survey into the other to integrate some of these surveys. And so there's a little bit of work along those lines, on parametric approach, although I have to say the only exposure I've had to it, I have never implemented that method myself, but I was able to satisfy myself that I could replicate his results almost exactly using the poverty mapping results. So working with exactly the same data set he used, he would estimate this on a sort of bivariate basis, produce the poverty rates on that basis, and then I was able to replicate his results exactly using our approach. So that was the one. So I think in some sense there was some encouraging results. It's a kind of an encouraging test, because in the context where you did have the continuous variable and you had the bivariate variable, we were able to get the same results. So that gives you some support to the idea of perhaps applying that method to other variables where you don't have the continuous variable, but you only have the bivariate variable. And of course, there's other applications that one could think of. I mean, one thing that I was very interested in was the context, well, suppose they wanted to estimate particular components of income. We want to do small area estimates of certain types of income, like income from non-agricultural activities. Well, then you're dealing with a situation where your variable, dependent variable in the survey will have a lot of zeros for those households that are not involved in the, and then have non-zero values for those who are involved. So you'd have to think of some kind of Tobit model or something along those lines for your estimation. It's not something that I've pursued yet, but it's something I think is really important and very interesting. But I'm afraid I don't have a whole lot more, and I would just reiterate what I think Isabel was saying earlier, that this is an area for real active research. So there's definitely more things, many more